I'm what? Hello, hello, hello. Hi, everyone. It's so great to be here and to finally learn about MCP for Java developers. I'm Sandra Ahlgrimm. I work as a advocate in developer relations here at Microsoft, and I'm here with the one and only Bruno Borges, Java champion. And what do you do at Microsoft now? You're muted.
I'm muted. I just said a bunch of amazing things, so I'm going to have to say that again. Hello, everyone. Good morning, good evening. I'm Bruno Borges. I'm on the developer community team. I work very close with the developer relations team. We do a lot of great projects together for the community and events like these. So welcome to Let's Learn MCP. This is the Java edition, and Sandra and I will have a great session here. This is a very interactive presentation, so please do feel free to comment your questions. And if you don't know how to, just go to the comment section on YouTube of the live stream. Sandra, so have you played with MCP already?
Yes, I did. So I almost use it every day, and I'm so happy and glad that we finally have a protocol for everyone to use. Like as a Java developer, I always need to see, or I want to see standardizations. So that's a very good fit.
Yeah.
And who has used it before? Please share in the comments.
Yeah, we'd love to know if you have already done something with MCP, if you have done a server, if you have done a client, if you have tried to do tool calling in your favorite AI UI. And this is the sort of talk that will help you build your own tool calling experience with AI agents. And what else? What else can we talk about AI, Sandra? Is it artificial intelligence? Is it statistics model? Is it like a very complex algorithm? What is it?
Sorry, Bruno, I had a connection issue. What was the question?
I'm asking. I'm asking. We can also talk about a lot about AI, right? Because I mean,
Yeah.
MCP is about AI. And I was asking, like, what is AI? Is it artificial intelligence, statistics model, math, algorithms? Can you just give like 5 words? You can use ChatGPT or Go Copilot if you want.
Sure, sure. So if I want to use something in a smart way, so like and also I want to edit with data. So oh wow. So I can have like a service that does something for me. So just imagine I'm the best driver ever, but I might have had a car accident, right? And after a car accident, I'm already stressed enough. So using AI, I can now have an app where I can just do a picture of the damaged car, and then AI will go in the picture and define what car it is, what brand, what's damaged, and then send it to the insurance.
Oh, nice.
What happens?
Cool.
Yes, and just imagine and it would be cool if I can even put that into an agentic system. So I have this app, and then my insurance company, they can kick off a process where they would already do an appointment at the repairing station for me. They might call an ambulance, depending, how
So you
what's
could.
the damage. They might send it to the police even.
Okay, that's the one tool that we don't want, right? In the whole flow. Don't send to the
The
police.
police
Yeah,
thing.
let's figure it out between ourselves first. But I saw one comment. It's like, yeah, all of the above, and I guess that is the right answer, right? Like, it's all of these things that we are talking about here. It is statistics model, the LLMs. It is AI agentic tools and models that can call other tools, and all these integrations between the systems so that the model can do these tool calling as it see fit, right? If I ask, hey, send these pictures to my insurance, it may already fill the form for us, right? With
Yeah.
the location, based on the location of the phone, it can fill a basic description of what happened based on the photos that are being uploaded. So I think this is an interesting use case. By the way, I hope you haven't had to use it yet, but
No, just in theory, because as I said, I'm the best driver.
so one question here: can you also talk about the difference between AI directly calling API versus MCP? So yeah, so when you open GitHub Copilot, or when you open Claude Desktop or OpenAI ChatGPT Desktop, and these interfaces, they have these capabilities, or these tools, right? AI directly calling API, it's calling those tools. MCP is a standard way for you to develop your own tools so that your AI system can make calls to these tools and standardize how you offer these capabilities, and then how these capabilities are consumed by the AI model. So great question. Thanks, folks. This is a great start for this presentation. So now let's get into a little bit of this presentation. So for the agenda today, we're gonna go into more details. What is MCP? How does it work? And how you can use it. We go into an in-depth overview of the MCP features, and then we're gonna build an MCP server in Java. And I hope everything goes as planned for the demo, because the idea is that we actually ask an AI agent, GitHub Copilot on Visual Studio Code, to implement the MCP server for us using a prompt that you can reuse later on your environment. So let's get started with. Oh yeah, and the tutorial is available in this link. You can look later. If this link is not working, it will be working after the transmission for sure.
It's working.
Sandra, you would like to talk about agentic coding? What is it? Because you mentioned that you have played already with this thing on Visual Studio Code and other IDEs. You want to give the audience a glimpse of this?
Sure. Okay, can you hear me double? Okay, great. Anyhow, nothing's working, but fine. Okay, so agentic coding is, I can use VS GitHub Copilot, for instance. So here in this screenshot, you can see how you can use it. If by default, I think the agent is not selected. So you need on the top, on bottom right, you can select agent here. And also you can switch the models, use whatever you prefer. If you have a little bit of time and go for best quality, I would always go with Claude 4 nowadays, but that's your choice. If you want quick answers, you can also select GPT-4o Mini, for instance. Yeah, and I select agent here because this will actually give my AI Copilot the availability or the ability to change files, edit things. And it's pretty cool because I ask it to do something and then it will always come up with a plan. And then I can do confirm, continue, please go ahead. And I must say that is working so much better nowadays. So I just did it to change my app to use GitHub Models, which is a tool to, and also available in CLI to actually check what prompts to use and also what models. You can actually test models against each other based on test data, which is a great thing, but another topic. So, and then if it goes wrong, so like for me, sometimes it goes wrong, right? AI can hallucinate, and as we said, it's based on statistics. It's just giving me the next likely token. So I'm like, I always need to be still the captain or the pilot here, so I can tell it, oh no, that's wrong, please also think about that. And then it will come up with a plan again. Then I do confirm, and then it changes all the files, does what it should do, and in the end I should have the feature up and running. It even compiles the code, which is kind of nice.
Yeah, so here we see that agentic experience doing tool call, right? So it ran a file, and then it suggests, hey, I think I should run this npm install command. This is the AI figuring out what to do next. But I mean, it's asking for the user permission because this will actually trigger a command in the local environment, and we want to make sure that the human in charge is reviewing all these tasks. So they know what's happening, and they can, if the AI comes up with a code or with a command that should not be executed, that's the opportunity for the human to intervene. But I think Visual Studio Code recently changed. Now the default mode is already agent. When you open Visual Studio Code and you have GitHub Copilot chat, agent mode is now the default. And Claude 3.7, I think, is the default now. So Claude, the Sonnet model, has a better understanding of coding, and that's why it's better to choose that first. If it doesn't work, which I doubt in most cases, then you can switch to something else. But choosing the model is part of the work of the human in charge. So number one, cost, and number two, the quality of that model. The lower the cost, the lower the quality, but then you can also do more with for less, right? All right, so agentic coding is that. So let's continue here. And then there's, of course, I mean, how do we provide real-time context? How do you connect to database, query GitHub issues, run tasks with natural language? How can we bridge this gap between the code, the client, and the LLM and everything else? And that's where, enabling all these tools in the environment, in the IDE, gives the agentic AI the capability of do a lot more than just answering questions. So the need for MCP arises a timeline. So we have these tools that are integral to an agent performance, and then all these services and tools need to talk to each other. It's very hard to integrate these things. I mean, for example, if you have ever done any integration with Google APIs, it's not that simple. I mean, it's well documented, etc., but it takes quite some work. So you want to simplify things. Same for SharePoint, same for Microsoft Graph, and databases and so on. So what you can do is expose all these things through a standard API, which is the Model Context Protocol API, so that the AI can call these things directly. and you don't have to write the code for every single thing. I mean, the developers of these products and these services will expose their capabilities, their tools, using the model context protocol specification. So that's where the standard came from, and why it's interesting. So
Finally, it really took a long time to get those standards, right? At all conferences, you had those talks about agentic system for XYZ, and everyone was building one. So it's so great that it was easy already. But then if they can't talk to each other, and especially if you want AI to make them talk to each other, you need a standardization. And as a Java developer, finally.
yeah, I think I myself got into this question. What is the difference between the MCP specification and Swagger and REST APIs, right? In practice, not much, because at the end of the day, when you build an MCP server exposed through a HTTP protocol, it is a REST API to some extent, but the MCP specification narrows what are the endpoints of this REST server, and that is the specification. So it can be seen as REST. I mean, you could expose a Swagger application to AI, and I mean, the AI, if the AI has a tool that reads HTTP servers and contacts REST endpoints, it can figure it out what are the things that can do with that. But it's not very standardized, and I think that's the beauty of the MCP specification. Standardize those endpoints so that the AI can know what tools are available, what is the documentation of these tools, what are the parameters of these tools, and there are even other elements that can also be exposed by an MCP server that the AI can leverage, such as prompts and resources. So you're going to look into those things to understand how MCP is unique in comparison to just exposing a Swagger contract. Okay, so this MCP specification was created by Anthropic. I mean, the AI community has been invested in it heavily. Microsoft is working with it. Google, Amazon, all the major vendors are on it, and lots of open source projects already built around MCP. And the cool thing about this is I think it's one of those specifications that was born in the past less than 2 years, and it already exploded in terms of like an ecosystem. If we saw like the adoption of TV and adoption of radio and how many millions of users those things in the consumer market achieved millions and millions of users in fewer and fewer days. MCP is the version of this thing for developers. I mean, developers have adopted MCP so fast that the evolution won't stop anytime soon. So I think it's fascinating to see a standard that is rapidly evolving with an ecosystem that is rapidly adopting at large scale. What is this question here? Interesting question. What is MCP sampling? Is it the MCP server calling back into my agent? How does that work? So I think the idea of sampling is that the MCP server exposes some examples to what can be done with it, so that the AI can have an idea. Oh, okay, so this MCP server does this, this, and this. Here's an example how I can leverage this information. So that's the idea, giving the MCP exposing context to the AI so that the AI can know what to do. Sometimes if you expose an MCP server with just the name of the tool and a poor description and no sampling, it's hard for the AI to know what it can do with that. So we are in this world of moving from prompt engineering to context engineering. The better the context for the AI, the better the output of the AI. And I think that also applies to MCP implementation. So always,
if you're still nervous, what is an MCP server? We get to that later.
Yeah,
here.
Yeah, for those still lost on that part, we're gonna get into that. But the MCP server, in short, MCP server. Imagine an MCP server as a REST endpoint server that you built with your Spring Boot application or Quarkus application. You have a REST endpoint. MCP server is in to some degree that, but it has some specialties and even different protocols that you can use. You can use HTTP, you can use servers and events, you can use standard IO, SDIO. but in the end, it's like a REST endpoint. So what are the parts of the MCP? So we have the hosts, where MCPs are, where the environment is running. So imagine the host as where the AI is working, the LLM is working. And then you have the clients within that host, which is the GitHub Copilot, for example, or even Windows is a client. And then you have the servers. So Azure is a server, GitHub has an MCP server, Playwright is a server, and so on and so forth. So all these things work together. So the host is where you host your context, you host your work, and then it has clients inside, which connects to servers. Okay, so Sandra, can you help me with now the deep dive, and then we can do this together? And if people don't like me explaining or you explaining, they will vote who does a better job.
Okay. So that does match fine. So we have our MCP client, as you already said, and it can use tools. So like if you created AI apps already, you might have used tools or functions so that my AI program can call other APIs and toolings. So that's still the same context we are also using inside MCP. And then we can use it to query resources, and it also, gives me the prompts. And my client will always reach out to my server, and it goes in both directions. And it also uses standard output and SSE, as you already said. I think that's coming later. Can you click again? Because then the slide would be there. Yeah, cool. So here we have, again, the tooling, which is model controlled, as said. And we can use it for different things, like to retrieve and search for information. So like, give me the model brand of the damaged car, and what is the name of this A thing, like, so next to the window, front window, if you might have hit another car. So what would be the name of that one? And then it would give me a message. You can also use it to update DB records and things. And yeah, and application controls, so you can change files, you can retrieve the API responses and change it as you're used to as a developer. And for your prompts, yeah, so you can make sure that you have standardized output, like JSON outputs. You can summarize transcripts. You can use it for document and Q&A purposes.
Yeah, so we can summarize this as the tools, resources, and prompts are the three major things that are the three concepts within the MCP specification, where MCP servers and clients exchange with each other, right? Mm-hmm. So when an MCP client connects to an MCP server, one of the first things that we'll do is list the tools, which tools can be used by the AI while interacting with that MCP server. But sometimes the AI needs some prompts or needs to expose prompts to the user to choose from to do some interaction. And that's where the prompts resource is quite useful. So that instead of just writing a documentation in the README of the MCP server, you can actually let the MCP server expose. These are the prompts that you can use with me that will do complex tasks using these tools and the resources that are available. So this allows the MCP client to know what the MCP server can do, and then orchestrate a solution to a given task provided by the user.
Mm-hmm.
All right, so let's dive into tools. So tools are basically the actions that the MCP server can do on behalf. So functions that the LLMs can call to perform certain things. So if I want a tool that, let's say, I mean, we have 4 examples here, but let's say we have a tool that checks if the irrigation system has been triggered last night. We can have if you are into home automation, you can actually have this MCP server connected to your irrigation system controller. and you can just go to your AI interface that has a connection to the MCP server and ask a question. Hey, did the irrigation system turn on last night? You don't have to go into the dashboard of your home automation system. You just can ask, or even use your phone audio. Hey, did irrigation system run last night? And we have this tool that connects to the irrigation system control unit and checks for the last time it ran and brings that information back. So another tool is, okay, calendar, which day is today? Because AI, if AI needs to have access to actual time services to know the exact time and date, otherwise it will just come up with the hallucination of what day is today. And you can ask, hey, did the irrigation system run last week? And like that 7 days difference, there is a second tool for a time service that will give the AI the right context of what time of the year is today, what date is today, and then compare with 7 days before. That's great. So tools are these things that AI can call.
And I'm totally amazed how powerful it is. It can do like so many things. Like here, it can actually compile my code. It can run tests and even execute command line interfaces, right?
Yeah, absolutely. So, a great question here from somebody. Can one machine be a client and a server at the same time? This is a fascinating thing. So, in reality, your MCP server can also be a client of another MCP server. You can implement your MCP server as something that actually leverages other MCP servers behind the scenes. If it is extremely required that you do that, the best architecture probably is, and I'm saying this as my opinion only, but the probably the best architecture is that your client knows all the servers, and then the AI will figure out how to interact with them. But you can implement your MCP server in a way that does also connects to other MCP servers. But then again, if you're implementing an MCP server that will be called by another MCP server, it's almost like just a REST endpoint that you're actually doing, and not because if you write your MCP, the first MCP server in a way that just calls the second MCP server directly as like a programmable API, then it's just a REST endpoint. But if you're implementing an AI agent inside of your first MCP server to then think if it should talk to the second MCP server, then you're implementing an AI agentic framework. So, or an AI agentic application. So it gets tricky, but it can be done. I would say it shouldn't be done, but it can be done. Okay, so here in this screenshot, we can see like GitHub Copilot accessing tools. Like one tool here is run npm. One tool here is navigate with using Playwright to catch the content of a web page, and then use the Playwright MCP server to take a screenshot of a web page. Because Playwright is this tool that runs a browser, a headless browser for you, and then the team of Playwright implemented the MCP server for it so that a agentic AI can interact with it more easily. So you can see the prompt, run the website and take a screenshot. That's the user prompt. So all he does is, okay, the app server is running, or actually now it's running. We get started with npm, and then access with Playwright, and then take a screenshot. So all these tools are available in the context, and that's what GitHub Copilot will do if you ask nicely. So how do you implement a tool in Java? Here is, a quick question here. What is the difference between Google agent to agent versus MCP? Honestly, I'll give you right away. I don't know the differences. All I know is they pretty much are offering the same ideas. Like they're offering the idea of allowing an agent to talk to another agent. That's or an AI to talk to other tools and other agents. That's basically it. But if you want to dive into the differences, which I haven't done yet, then we're going to need to research that. Maybe on a future talk. Thanks for the idea. Love it. So in this screenshot, I'm showing you how to implement a tool as part of an MCP server using one framework in Java. So you can see like it's pretty straightforward. I have an annotation called tool. What is the name of this tool and the description? Again, this is metadata that is important for the client, for the AI agent that is acting as client, to understand what are the capabilities and what these tool will do. So here it's for running the Azure CLI, and it gives a string command and then execute the CLI on that environment where the MCP server is running, which may be your own computer, or it may be a server, an actual server machine, and returns the output, which is probably the output of the command that was executed in that environment. So this is how you do it. I mean, the tool can be list the top 10 customers in my database, and then the implementation is a JDBC connection. It goes into the database, does a select with limit 10, a SQL command, gets the top 10 customers, brings back that as a string or as a JSON or as something that can be serialized back to the client in string. Okay, so some user controls. Here, this is more like the experience from the environment, from the host, whether that is Visual Studio Code or Visual Studio or any other IDE that has more controls about when integrating with MCP servers. So here we are in a prompt, and we can actually filter out some tools. I don't want the AI to use these or that tool because my prompt is very specific, and I don't want the AI to hallucinate or suggest that it should be running these other tools. So that's why I'm going to uncheck these tools here, as I have many in my environment, but I want to be very specific. So here it allows the user, again, to have full control what the AI may be able to do whenever it gives the user gives a prompt. This is cool. You can actually mention the tools in the prompts. So if you know the name of the tool, you can just type the hash, and it will list the tools for you, and then it will give you the experience for selecting. Okay, let's create a GitHub issue and assign to Copilot. So I'll just say MCP GitHub create issue. Now, I probably could have said in the screenshot here, go and create an issue with on GitHub, and then the AI would most likely select that one. But if you want it to be specific and not hallucinate, then you do the mention of the exact tool. So resources are URIs for content. And the idea here is to bring this content into the context so that your prompt can be more specific. And these files are, the idea of the files are files that are locally in your environment so that the AI can access those resources. So this is a little bit tricky because the idea here is that the MCP server will return a URI that will be fetched locally in the client. And it's a little bit complicated. And I think for me personally, it's one of the most complex use cases for MCP. But it has its use cases for sure when you want to AI to target a specific resource. So here are some use cases. All right, so I want to reduce the response token. So instead of the prompt of the AI just returning me the content of the file, just returning the URI of the file, so that the tokens of that file are not included in the response. Expose data files to the user. So again, the file is already there. I don't want to. I don't want. For example, calling playwright to extract the JavaScript. I don't want the content of that JavaScript file to be part of the output of the AI. The playwright tool already executed the code, extracted the JS file, and then the MCP server will just expose the URI of where that file is located, and that saves you a lot of money, a lot of tokens. Have you done anything with resources, Sandra? Because I still haven't found a good use case for it. I mean, these use cases make sense, but I have. I'm curious if you have tried.
I think not yet.
Yeah, I've been playing with MCP, and I was like, I still haven't found a use case for this, but okay.
Yeah, if you have a use case, use the comments, and then we can check on later. But we need to get our presentation done and to actually build the server.
Yeah. And then the prompts that can be reused, right? There is a cool thing now in Visual Studio Code with GitHub Copilot that you can have reusable prompts. And the idea of the prompts in the MCP specification is to be reusable, again, to allow the AI to understand and the user to be able to leverage these prompts for specific tasks that are complex, that may combine multiple tools, and the prompt is just a template for that interaction. Okay, so prompt use cases. You have some ideas here: /welcome, /setup, migrate DB, but just like tasks that will allow the user to call and see, okay, this is what I can do with this MCP. So let's just drill down here. What is the overall idea? So I have Visual Studio Code. I'm using GitHub Copilot Chat. GitHub Copilot Chat will have integration to a bunch of MCP servers. One of them is accessing local data in my computer. The other one is accessing GitHub API to interact with my repos. The third one here is just calling a remote server, which may be implementing another set of layer of web API calls to another remote server somewhere else. So all of these ideas here allow you to break down your elements, your components, your MCP servers in various ways. So if your company has a database, you can implement the MCP server for that database locally, just doing a database call from your local computer, but exposing as an MCP server, or you can actually host the MCP server so other users from the company can leverage that database using AI instead. So that would be the difference between these two ideas here. So now, Sandra, help us understand the landscape of MCP frameworks and SDKs.
Okay, so as we said, model context protocol came out of Anthropic, and there you can find official SDKs. So there's one from 4.NET C#, which was built by Microsoft. There's one for Java, which is built by the Spring team. Thanks for that. And then we also have one for Kotlin, Python, and TypeScript. As this session is for Java, we focus here on the Java SDK for MCP. And there we have this one for client and servers. And both use MCP session for synchronous and asynchronous operations. And I like the fact that we can also use it for client-side protocol applications. The MCP client is handling client-side protocol operations, and MCP server is the server-side protocol operations handler. And there's also something called a session layer, the MCP session. So that's where communication patterns and state are handled. It's the default MCP session implementation. And for transport, we have different options. So there is the STO output and also the MCP transport, which is handling JSON RPC messages, which is pretty cool. So you always say, yeah, it's a REST endpoint. But don't worry, as we all use microservices, we know that it will slow down our system and our architecture. So you can also go with RCP here, which makes it a lot faster. Come on. And yeah, so we do have the SEO transport, standard in, standard output for the core modules. And we also have the HTTP SSE transports, what can be used then by Java HTTP client or also for like Spring Webflows or MVC. Yeah, and as I said, it's by the Spring team. So they first had their framework in mind. So even though it's framework agnostic, it's using the project reactor, which makes it a bit harder for other frameworks to use it. So that's why other frameworks such as, yeah, sorry, I moved the cat out of the desk, but she will come back later. So like other frameworks such as Quarkus, they build their own MCP server or MCP integration. It's following the same standards, so you don't need to worry. It will both work together. I think we have it on the next slide, where you can actually see that there are frameworks such as LangChain for J, which can be used with Quarkus and all other frameworks, and then Spring AI. So we have Spring AI, which is like helping you using the MCP as Java SDK to build clients and servers. If you're a Spring developer, that could be a good choice for you, but you're limited on Spring. With LangChain4j, you can build clients in all frameworks. Quarkus also helps you to build MCP servers, and I think that's the one that we're using here today.
Yeah, we're gonna do a demo using the LangChain4j and Quarkus. But again, like Spring developers, you have great resources from the Spring team. There's the Spring AI library, which is the alternative to LangChain4j. Spring itself is the alternative to Quarkus. The MCP SDK is implemented using the project Reactor, which may or may not work well with other frameworks out there. So there might be conflicts of dependencies, etc. So that's why we even see like LangChain4j and Quarkus on one side and Spring AI on the other side, just because of how they're implemented. But if you're building an application that doesn't use a web framework or a microservices framework or cloud native frameworks like Quarkus, and let's say you're building a Java desktop application, either way, you can use LangChain4j or the official MCP SDK for Java with Project Reactor. So both alternatives are great. They work really well for an environment that you don't have these interdependencies between frameworks and libraries. But the moment that you go with Quarkus, for example, then working with the official MCP SDK is not ideal, because all these integrations from Quarkus are actually implemented already using LangChain4j. And LangChain4j itself is a library that is self-contained and independent from these other external implementations. So if one day the LangChain4j project decides to leverage the official MCP SDK, then things may become a little bit easier. But right now, the MCP implementation inside LangChain4j is independent from the MCP SDK from in coordination with the Spring team. All right, so if you want to see how to build an MCP server or client with Spring and the official MCP SDK, go visit the modelcontextprotocol.com website. They have a great tutorial there for you to follow through and implement your first MCP server. That documentation is very clear, very straightforward. We are here to show you the more complex way. No, I'm kidding. It's also an easy way to implement with Quarkus and LangChain4j. It's just different. And that's one of the fascinating things about the Java ecosystem. You always find two or more ways to do something because there's always two or more frameworks to implement something. So without further ado, let's get into the demo mode for this thing. So first, I want to walk you through briefly on the repo that you can access already. It's called the Learn MCP Java on the Azure Samples org. This repo has a series of tutorials, or actually 3 tutorials: project setup, MCP server, and MCP client. Here you're gonna work with Java 21, Maven latest version, VS Code with extension pack, and we're gonna use the Ollama local LLMs. So if you're not familiar with Ollama, it's this great tool here where you can download and run these local LLMs and many more actually on your own computer. One cool thing is you can actually filter out which ones have tool support. So here you click on tools, and you're gonna see which models can make tool calling. And for our task, we're going to be using the Llama 3.2, which is a small model, but still very capable for, at least for the purpose of this demo. Okay, so I have Ollama already up and running here. So you can see here the Ollama running locally on my computer. And with that, let's get into it. So how to get started? So this repo actually comes with the client and the server already implemented, but I want to help you. The documentation for the MCP server helps you build your first MCP server, and then the client walks you through the code that already is here, so you understand how the client was implemented. So let's go into that. Let's start it here. You can git clone, start the server, and run the client, or you can do yourself. So let's go to the part one. Part one is project setup. We already have all of these things. We do recommend using the Quarkus CLI so you can create the server using Quarkus in your computer. And then again, having Ollama running locally. After you install Ollama, you have to pull the Llama 3.2 model. And if you don't have Ollama running like I do have here, make sure that you are serving the Ollama endpoint. So an application or an AI can an application can connect to Ollama to interact with that AI model. All right. So let's get to part two. So building your first MCP server. Now this is the cool thing. I'm gonna actually create here a new window. Let's get into the terminal in this new window, and let's make dir live demo cd live demo, and we're gonna execute this tutorial, hoping for the best that everything will work as expected. So we're gonna create the server here, and hopefully everything works. There you go. So now we can actually open this this folder in a new Visual Studio Code window. Let me close this one. Okay, so now we have this Quarkus Maven project. It has no code, but it does have some dependencies already configured based on the command line. You can see here that I added some dependencies like REST client Jackson, Qt, and most importantly, the MCP server extension to build a Quarkus server-side application to serve an MCP. Okay, so there is one cool thing about Visual Studio Code now. It has this new feature for Copilot instructions. And this feature allows you to have these templates on your project so that when AI is thinking, it can actually take clues from these files with these instructions. And the file that we want to create here is, we can create a global file. It's called the github.github/copilot instructions, or we can create a specific .instructions.md file. So we're going to go with this one here because I don't want generic instructions. Generic instructions you're going to put in this file here. For example, always put a copyright statement in my source files. That's a generic instruction. That goes into this file. But if you have more specific instructions for use cases, then you use the instructions.md file. So let's create this one instead. Let's go back here and let's create the folder.github, new folder, GitHub, and then let's create a new file, Quarkus MCP instructions, new file. And then let's copy the content into this file. All right, so I saved it. And you can see the instructions are quite simple. Actually, the quick start here is not needed because we did run ourselves this command. But we did provide a few instructions. Let's use Java 21 with Quarkus. Let's use the MCP extension, use CDI for dependency injection, and expose the MCP endpoint on port 8080/MCP/SSE. In practice, this is not needed because this is the default in Quarkus, but I just put it there just to make sure the AI doesn't hallucinate or make any dramatic changes. These prompt instructions also have some ideas of how to organize the code. I want a model package, a repository package, service, and MCP. Use camel case for methods, Pascal case for classes, add Java doc. There's a bunch of cool things here. And then importantly, how to build MCP tools. They have to be public methods with application scope, CDI beans, and they have to use the tool to name clear description. So the thing here is this prompt you can actually reuse. This is available. You're going to be able to reuse to build your own MCP server later for whatever use case you have. And let's say, send Sandra an emoji whenever she has to submit an insurance claim just so that she can feel better about that. That can be your MCP server, right? But these instructions are generic regardless of the use case. That's the thing that you have to know. So, okay, the instructions are there. Now I'm going to actually give a prompt with a particular use case, right? My use case here will be something slightly odd. We're going to implement an MCP server using HTTP, using Quarkus that will have the following capabilities or tools. We're going to unleash monkey species. We're going to get monkey details, get a random monkey, and get monkey statistics. All of that, as long as we expose this sort of data from each monkey, given a species name, location details, population, latitude, longitude, where to find that species. And then finally, include a data set of monkey species in the code and add a few fictional species with different attributes. So now we're going to see some magic happening here, and fingers crossed everything will work. And as the AI generates this project for us, we're gonna see if it generates a project very similar to what we already implemented before this with the code that already exists in the repo. So let's just go back here, MCP server. And yeah, so this is the implementation. And then I asked AI to generate the README for us. And you can see it did implement the 4 endpoints that we asked for. It defined a data model. It defined a quick start. Here are the primary classes: monkey species repository, the species service, and the species MCP server. So, okay, so it's doing something here. It implemented, let's take a look at what did it implement here. It implemented the monkey species data model. Great, that's a good start. Now it's implementing the monkey statistics. So we know what are the statistics for the database of monkey species, total species, most accessed, et cetera, et cetera. So it's coming up with some ideas, which are actually not bad. And it's continues to follow the instruction. Now I'm going to create a service to manage the monkey species. Ooh, interesting. So it generated a monkey service. It found an issue with unused import. So this is great. Look at that. It's a monkey service. It has some species in it. A little bit fake. And as per request, where's the fake ones? There you go. Techno Monkey, a fictional cyber monkey that exists in the digital world. This is great. So now it's implemented the actual MCP server. Let's look at that. So the MCP server. Oh, there you go. So it implemented something here with a tool metadata, tool result. It did not match. The API is not exactly this from LangChain4j. So now the AI will get into the mode of figuring out what is the actual API to use. And this is going to be interesting. So it's going to use the Maven dependency resolve plugin to find what are the dependencies of this project. Now let me check what annotations are available by looking at the instructions file more carefully. I need to use tool instead of tool with tool metadata. Let me update the MCP server class. And it's going to update this file here. Let's see if it does that correctly. So while AI thinks, let's have a conversation in the chat. So any hardware requirements to build up the decent MCP server? It has to have a processor, memory, and a hard disk, and connected to the internet. Those would be my hardware requirements for the server. And of course, I'm being ironic, but in terms of what resources, how much CPU and memory, not much, because as long as the model is remote, like if you're leveraging OpenAI model or for the MCP server. One thing that you're going to realize that the MCP server itself doesn't actually run AI, doesn't actually communicate with LLMs, unless you want to, but you shouldn't. The idea of the MCP server is to expose tools, to expose capabilities that the AI running somewhere else can leverage. That is the primary concept, design, or principle for MCP server. is to allow the AI to do something. So, it's gonna keep asking me things here to fix this thing. So hopefully, perfect. Oh, okay. So it seems like it finished implementing the MCP server for us. So let's run Quarkus dev. Oh, wow. Okay. So it seems like I don't know why it's asking for a sleep for 10 seconds on a different terminal, but okay. Okay, so it implemented something. It's up and running. So now, actually, I need to fix this. So in the README, oh, actually, no, not here either. So let's go back to MCP server.
Okay, so there's a question in the chat. Can you explain again what is the difference between MCP client and MCP server and what to use what? So I would implement the MCP server to like in front of my interface. So like for my insurance example, the MCP clients app would be on my phone, and then calling the MCP servers like with the MCP server of the car fabrics, like to get the namings of the car. And also another server would be the repairing station MCP server, so they can actually already book an appointment for me. So that would be the servers, and the client would be on my machine, which handles like the requests, or not necessarily on my machine, but the client would be the app that calls the servers then. Do you want to rephrase, Bruno?
No, that's a great answer. Next question. Should MCP servers be designed with single responsibility principle in mind? I would say so. I would say make an MCP server specific to a certain, a small set of tools. If your MCP server is exposing dozens and hundreds of tools, I would say that is not a single responsibility principle for sure. So, for example, look at the Playwright MCP server. Playwright is this tool that allows you to programmatically interact with the browser, right? And the MCP server allows a very small set of capabilities, such as open this website, navigate, click on this button, fill in this text field, submit this form, scroll down, take a screenshot. Those are the capabilities that are what a human would most likely do while interacting with the website. So the MCP server exposes those tools or the actions that a user would actually take in the browser. Okay, so I'm just going to pause here because we are running out of time, but the AI continues to iterate over the MCP server implementation, but the reality is I feel like it did implement what we wanted. So I'm going to pause here and get rid of the task that implemented without need. And let's just go back to the server here, and let's do clean, verify, Quarkus dev. So GitHub Copilot implemented the MCP server for us using Quarkus and LangChain for J. Okay, so great. The there was an issue here. I don't know what happened. Let's see what happened. Created to log a stack trace. Okay, hopefully nothing problematic. So now let's test this thing. The MCP project has a cool MCP inspector that we can use to test. So you can run this command here. npx model context protocol /inspector. It gives you this web interface where we can connect to an MCP server. So great. So the MCP server is up and running. The client inspector is connected, and we can now list tools. And here are the commands: get monkey details, statistics, get random monkey, and list monkey species. So now let's run this one. Good. So here is a list of monkey species, and it did implement some fictional species. So let's look at this one, and let's find where in the source code is this species. There you go. So it's on the monkey service class. It added real species and then fictional species, and it's up and running. Cool. So now all we need to do is understand the code. So let's close this one here. Let's go here and let's just expand so you can learn. So this part here is very straightforward. Just creates a set of monkey species and exposes the data to for the MCP servers to expose publicly. Get random species, get statistics, get species names, get all. There you go. Cool. So let's go to the monkey's MCP server, the actual code that we want. So, okay, here's an inject. It's going to use the monkey service, and it's going to expose a tool. The tool is list monkey species. We saw that in the inspector. There's this other tool, get monkey details, get random monkey, and get monkey statistics. It implemented what we asked for. This is fascinating. And then finally, let's go to the client. Okay, so we have the server up and running here. There's some errors here that I don't understand what's going on, but that's fine. It's the server, the MCP server is actually working. So let's open a new window and let's look at the client. So we're gonna look at the code. This is the code that is on GitHub. You don't have to implement a client yourself. I'm just gonna walk you through it so you understand what this is about. So first things first, when you open, there is this mcp.json file, and it's already configured to the default path of that MCP server that we implemented. And the first thing that we can do here is just, maven clean verify. And then we can actually run the jar file, java-jar, the jar file that got created here. So this is a command line tool. It has two commands you can see here, the chat command and the tools command. Tools command lists available MCP tools from registered servers. So let's do that. All right, so it did connect to the MCP server, right? Here's the registry file, the mcp.json. It connected to the MCP server and identified 4 tools. Here they are, get monkey details, get statistics, get monkey, and list monkey species. But this command line app has this thing called start a session. So we can talk to the AI. So let's go into that. So it's gonna connect, and voila, I'm connected to the local or llama 3.2, and I'm connected to one MCP server, the monkey MCP. And this gives me the idea of, can I talk to you about monkeys? It looks like I generated a list of monkey species with fictional characteristics. It seems I got sidetracked from providing information. So let's try again. List monkey species for me, please. Okay, so it did list a few. Proboscis monkey, howler monkey. I apologize for the earlier list with fictional monkey species. Here's the list of real monkey species. Give me the list of fictional species. All right, so remember the techno monkey? Here it is. Techno monkey is coming from our MCP server as the others. One thing that is interesting is once the MCP server responds to the model can actually enhance the information if it feels like it should enhance the information. So this text here may not be exactly what is in the MCP server, just because I'm asking to give me a list. So the list may not be exactly. The AI may treat that information and expose back to you in a more natural language way. So if the MCP server returns a JSON file, for example, the AI has to transform that JSON file into natural language. So as part of that transformation, it may enhance the information in a way that works better for you, for the user. Yeah, there is this warning here. This is a problem that keeps reconnecting to the server, but it still works. It just tries to reconnect. It's a warning. Should be cleaned up. So let's take a look at the oh, actually the other thing that we implemented on this client is you can actually type exit and it says goodbye. All right. So how is the client implemented? So there's a framework in Java called Pico CLI. I think it's picocli.dev. I don't know the URL, so search on Google for Pico CLI and Pico CLI. Yeah. And it is this framework that allows you to implement command line tools in Java. So here I have the command, which is my main application. Here's the method main. It's a new command line application, and it's going to connect to my MCP client application. The MCP client application is going to load the configured logging file. We'll load the login.properties file, just try to minimize logging from the different libraries. But other than that, it's what was implemented in the chat command and in the tools command. So let's look at the tools command first, because that's what we did. So the tools command will use the class tool service. The class tool service is what registers the MCP client for us to look into the server capabilities. Here we're going to list the available tools, and then for each tool, we're going to print the tool name, description, and parameters. That's what we saw here in the output earlier. There you go. Tool name, description, and parameters. And with that, we just shut down the service. So let's look at the service for class. Register MCP servers and then initialize the tool provider. So register the MCP servers, just look at the JSON file. So it looks at the configuration input stream here. It parses the JSON file using a JSON library in Java. And then for each node in that JSON file, it registers the server. Let's look at that. There's a server name and a server config. The server config has the URL and the type. And then for each server, it creates the MCP transport, HTTP, for the SSE URL, and then implements an MCP client for that particular transport. And then I have a list of MCP clients. So technically, my JSON file can actually have multiple MCP servers for this application, for this client application. Once I have the MCP servers registered with different MCP clients, I can now initialize the tool provider. The tool provider is what the AI agent requires so it can interact with the different tools. So here I have the tool provider. The tool provider may have multiple clients. I'm converting all the clients list into the list of MCP clients for this tool provider. After this is done, I can go back and now I walk you through the chat command. So the chat command is when I type in the command line chat, and I'm going to use the chat service. If the chat service is available, meaning Olema is running and the MCP is running, I'm going to start an interactive chat, and that's what we saw in the command line. The interactive chat will print information, which is this startup message here, which is there you go, right here. Starting chat with Olema. There you go. And then it starts scanning the system input, which is the terminal. For every message that the user inputs, I'm gonna send that message to the chat here. Unless it's exit, quit, or buy, then I shut down the application. But if it's not, I'm gonna chat. I'm gonna use a random user. The random user is just for the sake of having some memory, so that the chat, the AI agent understands the previous messages that I already sent. So it has a memory. And for each session, I send the input. Now, how do I implement this bot? Let's look at this bot here. This is part of this implementation. Now we get into LangChain for J-code. In LangChain, you define a bot or an AI agent by implementing this interface. It's just a Java interface. And actually this line here is not required. I'm gonna get rid of that. I'm going to have a system message. You're a helpful AI assistant. You can answer questions, use available tools to provide accurate and up-to-date information. And this is just a Java interface with a memory ID for the first parameter and the user message for the second parameter. Okay, I have my AI bot, AI agent definition with the system prompt. Now let's get an instance of that bot. Well, to have an AI agent bot, we do need a model. So you're going to use the Ollama locally. So LangChain4j has this integration with Ollama. You have to set the base URL where the Ollama server is running. You define what is the model. You define a timeout for responses. You can set some adjustments like temperature, and then you build the model. This gives you an instance of chat model. As I said, we do have a memory so that your messages have correlation between them. So you ask, where is Canada? Canada is in North America. Okay, how many people live there without saying the word Canada? So it will know that you already asked about Canada. So therefore, the next question is about Canada, probably. So that's what we use memory for. And now here's the trick. I'm going to give the tool provider from the tool service where we register those MCP servers. And this is what gives the bot that LangChain will implement using the interface the information about the MCP servers and its tools. So for that bot, AI services.builder bot, we're going to have a chat model, Ollama. We're going to have MCP servers, and we're going to have memory. From now on, I have an AI agent bot on my application, and I can interact with that however I want. This is a little trick that I found that I came up with to do a health check if everything is up and running. So you can see that I'm using a memory ID that's different than what I'm going to send later. And I just say yes if you're ready to chat. And if there is a runtime exception, it's because either Ollama is not running or the MCP server is not running. Something went wrong and the bot is not available. So we just shut down. But if everything goes fine, chat initialized and chat model and bot are not null, it's ready to talk. And then going back to the chat command, if it's available, everything got initialized, we're gonna start talking to the AI on an interactive chat. So this client is very simple, very basic. It just uses two libraries, the Pico CLI, so you have the command line interface, and the LangChain4j for interacting with the AI model and doing MCP clients. But you can actually ask GitHub Copilot, like I showed before, to implement your MCP client however you want, given that you have the information about your MCP server. And then if you want to use Spring AI, if you want to use LangChain, if you want to use Quarkus, if you want to do a Node.js client application, if you want to do a JavaFX or Java Swing desktop application, there are many ways that you can implement this thing. So this finalizes our demo. If you want to understand how the client was implemented, just look at the next file here, which is using the MCP client application. It walks you through everything that I had for this demo. Having the server up and running, and then using the client commands. And then you can feel free to tweak this code. That's the beauty here. You can just go to GitHub Copilot chat and say, hey, change the use case. I don't want monkey species. I want car insurance, car crashes photos. And make sure Sandra is involved, in a way, right? So that is the cool thing here. You can just play with it from however you want, to do whatever you want. All right, so this finishes our presentation. Let's see if we have more questions here. I have
quite a couple. So one of them was, how do we do authentication? So we do a server, and then we want to make sure that only the right people can access it. How would you do that?
So that the MCP specification has an authentication mechanism defined. And different frameworks, different libraries are still catching up with that. So not every library out there that implements MCP specification supports authentication yet. So you would really need to dig into which library you're using to make sure that it supports. I do think that LangChain4j with Quarkus does support already, and so is Spring AI because of the MCP SDK. How to actually do that, that's not a part of the demonstration here. That's not part of the today's talk, but great idea. We're going to keep that in mind for our next event. So what else we got here? When building an MCP server for an existing application, it's better to have it running in a dedicated instance. I'm wondering in terms of resource consumption. If you have, let's say you have a RESTful application, and this RESTful application, you also want to make it available to MCP clients or AI agents. I would say it's just easier to expose a subset of all the APIs of that RESTful application as MCP tools, and you can narrow down only to the specific things that you want AIs to do with your API. So I wouldn't break that down. But if you have a complex system which has, let's say, 15 microservices, each one their own RESTful application, and you want to expose all of them to the AI, maybe you want to collect which capabilities from each RESTful application and then expose as a specific MCP server that does all the coordination for you. So that would be my suggestion as a starting point. Let's see what else.
There are also a bunch of questions. What language to start with? Learning coding, and then there are some people claiming that Java would be slow, and then others saying, yeah, you can start with Python. If you do, congratulations.
Yeah, I mean, so if you want, we're gonna have this series, Let's Learn MCP. We have talks in C#, Java. This one we have talks in Python, and we have talks in TypeScript. So keep an eye on the schedule, and you're gonna find out other sessions that will give you live demos for specific languages and frameworks. So one last question here. I have an existing Spring Boot app. I am exposing REST APIs for my client. Can I now expose it as MCP so that AI can use my app? Is this thought process correct? Yes. We just walked through, right? So if you have a RESTful application and you also want to make it available to AI agents to interact with, just go and add MCP endpoints to it using whatever your framework allows you to. Since you're already using Spring Boot, you should be able to use the Spring AI as part of your application to expose MCP server endpoints for specific cases of your application. That is exactly what you should look into. That's a great question, by the way. Thank you. Let's see what else. PHP? Yeah, I don't know PHP. I mean, probably there's something in it. I mean, PHP MCP server. Let's look at that.
Yeah, there is one. So if you have high demand, just ping us. And otherwise, we do have a lot of resources. Why don't we get back to the slides to finish it up?
Yeah, exactly. So answering the question, yeah, there is a PHP MCP SDK. Well done. All right, going back to the slides to wrap up. Okay, so we implemented MCP server. We use an MCP client. Gave you some ideas. So model context protocol at Microsoft. A lot of the things that Microsoft are now supporting and offering or being exposed as MCP servers. I mean, Playwright is a good example. GitHub is exposed as an MCP server. Azure is exposed as an MCP server. And you have all these clients and hosts. We showed you Visual Studio Code with GitHub Copilot chat extension. GitHub Copilot itself on the web browser, when you're on github.com, there is a GitHub Copilot now button over there that you can interact with. And that GitHub Copilot experience does have access to some tools curated by Microsoft. Microsoft Teams is a client of MCP. And then you have all these layers also down below where you have the Java MCP SDK and other libraries like LibChain for J and Quarkus. You have the C# MCP SDK and places where you can run your MCP server as well, such as the Azure Functions. Azure Functions has now an API for defining MCP servers and Azure Functions. And This is all thanks to Anthropic's team who implemented, defined the MCP specification, and it's great work from them. And it's great that the model context protocol is a specification that is being developed in the open with lots of contributions. I mean, the whole authentication specification, for example, is heavily it's done in close work with Microsoft. Microsoft team is working very close to Anthropic on implementing, defining and implementing the authentication mechanisms of MCP. The other thing, so we have this MCP Dev Days coming. So keep an eye on this URL, aka.ms/MCP Dev Days. This is an opportunity for you to get hands-on experience with implementing MCP servers, MCP clients, and customizing your AI agentic flow. So if you want to learn more, here are all the links. Again, if some link here doesn't work, it will work right after this presentation. And register for the MCP Dev Days on that link. You're gonna have a great opportunity to learning more details on labs and deep dives with the speakers and presenters. So with that, I would like to thank Sandra for joining me in today's event. We hope you enjoyed. Please leave a comment on what was most helpful for you, what was most useful. We'd love to hear your feedback. And if your native language is not English, we're gonna have a few sessions in other languages. For this talk, we're gonna have German. So Sandra will be presenting in German. We have Yoshio Terada from Japan, Microsoft Japan. He will be presenting in Japanese, and I'll be presenting one in Portuguese as well in the next coming weeks. So again, thank you so much. Thank you, Sandra, for joining us.
Thanks for having me.
All right. You all have a great day and a great evening, and see you next time.
Bye.